Hey, welcome back to my YouTube channel. I am Xavier Smith, and today I'm going to talk about everything trigonometric expressions. That includes verifying identities, finding the values of 5 other trigonometric functions for theta, and simplifying expressions. So let's start with the 5 other trigonometric functions for theta. So cosine theta equals 5 over 6, and our domain is 3 pi over 2 is less than theta is less than 2 pi. So I always start with a right triangle. Or you could start by saying what quadrant you're in. 3 pi over 2 to 2 pi is quadrant 4. In a quadrant 4, sine is negative, cosine is positive, and tangent is negative. That means their inverses are also the same sign. So I always say this bottom angle is our x, and then we have our right triangle over there. And then cosine is 5 over 6, so that's adjacent over hypotenuse. So this adjacent is 5, this hypotenuse is 6. Now to find the missing angle, we are just going to Pythagorean theorem this. 5 squared plus y squared equals 6 squared. So this will be y squared equals 36 minus 25 is equal to 11. So y equals root 11. So this is root 11. Then I just erase this work, and then I just start. We have cosine, so that means we can get its inverse of secant real easily. This will be 6/5 because it's the reciprocal of cosine. Then I'll just go to sine, and that will be root 11 over 6, but it's negative, so it's negative root 11 over 6. When you're going to cosecant, you could say, oh, well, just flip sine. It'll be negative 6 over root 11. Then you rationalize, and you'll have negative 6 root 11 over 11. Then we go to tangent. Tangent will be root 11 over 5, but it's negative, so negative root 11 over 5. And then cotangent, well, we can just flip this over, or we'll say adjacent over opposite. It's 5 over root 11. Rationalize, you'll have 5 root 11 over 11, but that is negative as well. So 5 root 11 over 11, here are our answers. Now we have secant theta equals negative 9/4. Our domain is pi over 2 is less than theta is less than pi. So from pi over 2 to pi is quadrant 2. So that means sine is positive, cosine is negative, and tangent is negative. Now draw our triangle. This is like x down here. Excuse me. Then we have secant is inverse of cosine, so it's hypotenuse over adjacent. So this is 9 over 4. Now we do our Pythagorean theorem. Excuse me. Then we'll have 81 minus 16. 80 minus 16 would be 64 plus 1 is 65, so y squared equals 65. And y equals root 65. So we have root 65 here. Now we'll just solve as always. I'll do our answers in black. So we have secant, that means we can get cosine of negative 4 over 9 by taking the reciprocal. And then we can go for sine. Sine will be root 65 over 9. Then we'll go for cosecant. Cosecant will be equal to, flip this over, you'll get 9 root 65 over 65 because you've got to rationalize. And you'll get tangent is equal to root 65 over 4, but that is negative. Then cotangent will be 4 over root 65. Rationalize, you'll have negative 4 root 65 over 65. So our answers are just scattered. Now, for simplifying the trigonometric expression, we are just going to start. So we have cosine squared x divided by cotangent squared x. So that'll just be cosine squared x. I'm going to simplify this cotangent squared. Well, say what it really is. It's that is not sine. It's cosine over sine, so cosine squared x over sine squared x. Remember, when you're dividing by a fraction, you're just going to multiply by the reciprocal. So this will be cosine squared x times sine squared x over cosine squared x. These cosine squareds will cancel, and you'll get sine squared x with your simplification. Now we have cosine squared x tangent squared of negative x minus 1 divided by cosine squared x. So we keep this cosine squared x. Then we'll do negative. You can pull this negative out of the x. It'll be negative tangent x squared minus 1 divided by cosine squared x. Then you keep this cosine squared x here. And then when you square this negative, it actually gets rid of the negative. So you'll just have tangent squared x. So that negative is just gone over cosine squared x. Then this will be cosine squared x times sine over cosine, sine squared x, or cosine squared x minus 1 over cosine squared x. These cosines will cancel. You'll have sine squared x minus 1 over cosine squared x. This looks like a Pythagorean identity, but it's not. That is, the Pythagorean identity would be 1 minus sine squared x equals cosine squared x. So we have to take a negative out. It'll be a negative of 1 minus sine squared x divided by cosine squared x. Take this, negative cosine squared x over cosine squared x. Cancel these, and we get negative 1. Now, on to verifying the identity. So what we have to do is we have to keep one side the same as it starts, and then make the other side equal to it. So our first problem is sine x plus cosine x cotangent x equals cosecant x. I'm going to keep cosecant x the same. So I'll just do sine x plus, first I'm going to simplify this cosine and cotangent. So cosine x and cotangent is cosine over sine equals cosecant x. So sine x equals, this will be cosine squared x over sine x equals cosecant x. Then we are going to, sorry, that's a plus. We are going to get a common denominator here on the left side so we can simplify everything. So that means I have to multiply this sine x by sine x over sine x. That'll give me sine squared x over sine x plus cosine squared x over sine x equals cosecant x. Now, what you can do is sine squared x plus cosine squared x is equal to 1. That is our Pythagorean identity, and that'll just be 1 over sine of x equals cosecant of x. 1 over sine x is equal to cosecant of x, so cosecant x equals cosecant x. That is correct. We just proved that identity. Now, let's do our next problem. 1 plus cosine x divided by sine x plus sine x divided by 1 plus cosine x equals 2 cosecant x. Again, I'm going to keep this right side the same of 2 cosecant x. So what I'm going to do is I'm going to get a common denominator, meaning that this first 1 plus cosine x over sine x has to be multiplied by 1 plus cosine x over 1 plus cosine x, and sine x divided by 1 plus cosine x has to be multiplied by sine x over sine x, because that's just multiplied by 1, so it's not really changing anything. So this 1 plus cosine x times 1 plus cosine x and then it'll all be under the same denominator, so then it's like sine x times sine x, and we know that equals 2 cosecant x, and this is all over sine times 1 plus cosine x. Now, we're just going to distribute all these FOIL. So 1 times 1 is 1 plus 2 cosine x plus cosine squared x, and then sine x times sine x is sine, that'll be 2. Oh no, sine x times sine x, yes, is sine squared x divided by sine of 1 plus cosine x. That got really messy there. So we know cosine squared x plus sine squared x is Pythagorean identity. So that is equal to 1. So we have 1 plus 2 cosine x. So 2 plus 2 cosine x divided by sine 1 plus cosine x. Now, what we can do is we have to find a way to get rid of, so cosecant is 1 over sine. So we know this sine will stay in the denominator, but we have to find a way to get rid of this 1 plus cosine x. And what I see we can do next is take out a GCF, our greatest common factor, from the numerator, which would be a 2. So let's start with that. We'll take a 2 out, and that'll be 1 plus cosine x. See, because that'll be 2 plus 2 cosine x over sine 1 plus cosine x, and then that cancels. So now we have 2 over sine. That's the same thing as saying 2 times cosecant. So this is 2 cosecant x equals 2 cosecant x. So thank you for watching and getting through this video, and I hope it was helpful.